Ask an Astronomer here with our astronomer who is just two doors down from me on unceded territory of Musqueam, Squamish, and Tsleil-Waututh, and that is Marley. Hey, Marley, how's it going? Did,
It's
did you did you
good.
miss me 2 weeks ago?
Yeah, kind of.
You and Matthew did a great job. I watched while I was in Ottawa for the Canada-wide Science Fair,
Yes.
which was super exciting. So many amazing young minds, including a whole new aerospace category that they have for the first time ever at the Science Fair. Jeremy Hansen was there, along with
Nice.
the Canadian Space Agency. So really trying to push some of those engineering, but a lot of Mars biology. That was like a theme that I saw in that category. A lot of kids are trying to think about how to grow plants, not only the Mars, but the moon, something as we're getting closer to humans being in space for longer periods of time.
Yeah, it's hard. Like it's something we'll need to do, and neither of those places are particularly hospitable to how we live. So, that is an important question for sure.
All right. Well, we got a fun episode today, which is going to be kind of like a roundup of some fun news and things. Of course, June is exoplanet kind of themed month for us here. So we'll try to pull on some of those news stories for the astronomers this month, but we also got some fun stories to catch up to. If you are out there watching on YouTube or maybe even on Instagram, drop a question in and we will answer all and any of your questions until we hit the half-hour mark. Marley, let's get started here and let's get going with some exoplanet news. Alien worlds, have we found any life yet? What's going on there?
No, no life yet.
Oh,
Actually, probably like worse. I picked a planet. This is a bit of older news. It came out in 2023 of March, but I picked this planet 55 Cancri E because it's one that we talk about a lot at the Space Center. It's part of our Planet Hunters ground station show. We talk a lot about how inhospitable this world is. So this world is what we would consider a super Earth. It's a rocky exoplanet that is significantly larger than Earth is, but it's smaller than Neptune. So this is a problem we have with exoplanets. They come in all these different shapes and sizes, and we really only have our own planets for size reference. And so things that are rocky and larger than Earth get super Earthed, and things that are gaseous and smaller than Neptune are Neptune-like, but we try not to mix and match the rocky and gaseous worlds when it comes to size. But this planet, 55 Cancri E, it is really, really close to its star. It's like 0.015 astronomical units away from its star. And for reference, Earth is 1 astronomical unit away from the sun. This planet is so close to its star that it does one full orbit in 18 hours. So it
no.
is moving. It's very hot. It's not a place we would live or hope to find any type of life because it's thought to be covered in molten rock. with it
Okay.
yeah, with it being so hot and so close to the star, like the surface has never cooled down, right? It's molten, it's melting. It's not a place we'd want to go. What was
Isn't this
interesting,
the one that we thought would be Mustafar, where
yeah,
Darth Vader is hanging out?
exactly. Yeah, almost, yeah, bad. But what good question about that is what would the atmosphere look like on a world like this? So this is
Okay.
also part of kind of the James Webb Space Telescope's scientific mission is looking at exoplanets and not necessarily detecting them, though it has confirmed exoplanets before, but trying to figure out what their atmospheres are made up of. Because even though this world, for what we know, is not a world that we hospital, it's still interesting to figure out if it has an atmosphere and what that looks like. We know that the two innermost TRAPPIST exoplanets don't have any noticeable or effective atmosphere as far as we can tell with Webb's data. And those are very close to their star as well. But what's going on with a planet like this? For a while, it was thought that if the planet had an atmosphere, it would be one that was made out of vaporized rock, which is a very interesting thing to think about, an atmosphere just being chunks of rock. So Webb did take a look at this. And this is the emission spectrum or the thermal emission spectrum that came from two of Webb's scientific instruments, NIRCam and MIRI. So NIRCam looks at the near infrared wavelengths and MIRI looks at the mid infrared wavelengths. So it gets us a bit of a larger picture than if we were to just use one or the other. And what this spectrum is showing is the brightness of the different infrared light emitted by the planet, Cancri, 55 Cancri E. And they have two different models listed on the like shown on the spectrum. So this red line, this red jagged line, is the model for an emission spectrum if the planet had a rock vapor atmosphere, which is what we kind of expected or thought it might have based on what we knew about the planet. Model B is showing us the emission spectrum if a planet has a volatile rich atmosphere. So a volatile, is something like carbon dioxide, carbon monoxide. Water is considered a volatile, but in this instance, we wouldn't expect to find water. They were focusing mostly on the carbon dioxide and the carbon monoxide, not just vaporized rock. And then these little yellow dots and the little purple dots are showing the data that was gathered using Webb's instruments. And all of the data that they looked at, it fits much better with the volatile rich atmosphere. So
Okay.
from this, we scientists have kind of concluded that the atmosphere around 55 Cancri E is most likely an atmosphere rich in carbon dioxide and other volatiles, not just vaporized rock. And how that carbon dioxide got there is if the atmosphere had been outgassed from the magma ocean on the surface, that this magma, as it's bubbling, is outgassing different volatiles, and those end up making up the atmosphere of the planet. And the other volatiles they're talking about are volatile content that are similar from Earth's mantle. So what we would find in Earth's mantle, those types of elements and molecules are what they're anticipating and somewhat detecting in the atmosphere of this exoplanet, which is kind of
Okay.
neat.
Yeah, and when JWST was first launched, this was one of the things that we speculated that it was going to help us to do, was to go and peer in a little closer to these atmospheres. That carbon dioxide reading, of course, I think got a lot of people excited because of very simple kind of like correlations. Carbon dioxide, are we talking about life here? We even had a question as soon as we started talking about exoplanets on Instagram, are we talking about aliens here? But as you're saying, there are other explanations for carbon dioxide, not just byproducts of life.
Yeah, so those types of detections, like I know there's a bunch that we call like biosignatures, right? When we think about biosignatures, we're not just thinking about the presence of oxygen, carbon dioxide, ozone, methane. Them being there is not necessarily enough because there are natural processes that are separate from life that can create those molecules and create those things that we find. When we think about methane, carbon dioxide, oxygen, ozone, and how it relates to Earth, we're looking at the content or the concentration, like how much is there, right? So if we were looking for, like one of the easiest things to look, well, not easiest, but one of the easier things to look for would be a planet's atmosphere that has a very similar profile to Earth's, including this overabundance of carbon dioxide, because we would be detecting pollution, right? Our atmosphere has been modified by what we've been doing here on Earth. And so if there was an intelligent species who had the same things that we've done here and have polluted their planet, we would detect an excess of carbon dioxide. And that
Mhm.
excess would signify something's happening on the surface separate from a natural process. So just having carbon dioxide or carbon monoxide isn't enough. It's the quantities at which you have it in, along with other detections as well. Just because we have it doesn't mean it's life-based. It can be created by other natural chemical processes that go on the surface of a planet as well.
Okay, well, we're getting closer to that answer. I know that back in the 80s, when exoplanets and alien worlds were very much science fiction, that has kind of changed a lot now. And obviously, exoplanet research is at the top of, I think, a lot of astronomers' wish lists, especially with the missions when you look at JWST and what it's telling us and getting us more information, getting us closer to that answer. Although, here at the Space Center, we have to, of course, temper people's expectations because every time that we talk about exoplanets, we're like, well, how closer are we to life? And even as I can see in the comments here, there's one comment about the Harvard study of aliens, coming to us and figuring out where we are in that perhaps multi-planet spectrum of life. But really, when we're looking at the data, we're actually not really that much closer to it, right?
Well, I guess it's like we're one planet down. I don't want to say that we're like not any closer because even though we're not necessarily finding what we want, if what we want to find is life on another world, we're closer in the sense that now we know what not to look for. Like
Mhm.
here's another instance where we're like, no matter what the result is, we still learn something from it. Like learning that this incredibly hot, weird, destructive, violent world has an atmosphere still, even though it is so close to its star, can still give us insight about planetary formation and how things change from the protoplanetary disk and from a protostar and the evolution of the world itself, right? So we still get questions answered, and we still learn something, even though it's not the result we wanted. And that's, the careful thing you have to do with science, is you don't want to go into it looking for a specific answer, right? That can cloud your observations, that can cloud your interpretation of the data. You go into it just wanting to know something. It's like, okay, let's just look at this planet and see what it says. And we can build models based on what we think, but that's based off what we know and previous observations. But it's dangerous to go into it with an expectation. The, like, if you have a hammer, everything looks like a nail sort of thing. Like, you don't want to do that. And so it's not that we're further away or any closer. It's more that we've still learned something. We just didn't get an answer that many people would want to hear. Everyone, I think, wants to hear, oh, we found life, we found a planet suitable for it. But even when we don't, we still learn really valuable information that contributes to science in just a different way.
Yeah. Well, maybe just a comment briefly on the Harvard team that are usually very controversial when they come out with some of their studies, especially when it comes to Oumuamua, being alien crafts coming in, or it's like speculation. And I think for us here at the Space Center too, when people come to us with these questions, they're also seeing, Harvard, and they associate it with being very prestigious. But of course, this process, these are theories, right? And even though there are these, I believe, correct me if I'm wrong, that Harvard are in the minority in this thinking that there are intelligent life in the universe. But from your perspective, how do we unpack sort of like the information that we're getting about potential life in the universe?
Well, it's still potential, right? Like, it's not a given that it's there. It's not a given it's not there. In reality, we don't know. As all we know for sure is that we are the only ones here. We haven't found anybody else. And even like the team from Harvard, who it's not the Harvard institution itself, it is one specific group and one specific scientist who is very polarizing in the community. So I don't want to jump into it. I don't personally agree with a lot of what they've put out, because there are better explanations for what has been put forward, right? It would be fantastic if it was, life out there, but there's arguments that the data matches with better. And so that's what you have to go with, even if you don't like it,
Right.
And, maybe we're all wrong, maybe everyone, 99% of the community who disagrees is completely wrong. And if we're wrong, congratulations to them. But, there's better explanations. And that's part of it too, right? You have to just accept what it shows. And even if you're hoping for one thing, it might not be that. Is there life out there? Probably. I think, yeah, probably. There's a ton of planets. Does it look exactly like us? Probably not. Would be cool if it did. How are we going to find it? By looking and learning from every observation we make, right? So that's
There you
my
go.
spiel on that.
Well, I mean, it's great because honestly, these are questions that we get on the daily. Like when I'm in the
Yeah.
planetarium and you're doing a show, that is one of the number one questions that you're going to get. You're going to get that question because people are thinking about it. But I think people are also asking it in a way that they didn't used to ask it before,
Yeah.
when it was like very like pie in the sky idea, because we are getting some of this data. So it is getting very exciting. So really cool stuff, Marley. Thank you so much. We've got a couple fun stories we want to end off the show with that I thought was really fun, and something that for you out there watching, you can get involved in, which is potentially naming a quasi-moon of Earth. And yes, I said quasi-moon, not the moon. It already has a name, but we have some of these other objects that are floating around out there. So Marley, why don't you tell us what's going on here with these quasi-moons?
Quasi-moons. Yeah. So the Earth has a moon. We know
I'm
it.
aware.
We are, yeah, in case you didn't know, breaking news, Earth has a moon. It is what we call technically a natural satellite. So it is a naturally occurring object. We did not make it. It's not one of our communication satellites, and it orbits Earth specifically, right? It very clearly spins or moves around us. We have artificial satellites, which are, satellites, things we've made, debris from rocket launches that also orbit Earth. The natural satellite, the moon, its name is the moon, and that's kind of spread out to how we name other natural satellites of other bodies. They are the moons of Jupiter or the moons of Saturn. And then there's these things called quasi-moons, which are not moons technically, but they appear to be moons because they appear to orbit Earth as they orbit the sun, or orbit planets as they orbit the sun. There's a couple episodes ago, we did one on Venus's quasi-moon. I didn't want to repeat a bunch of information. Also, I didn't have time. So if you're interested in Zoozve, if you're interested in that, go check out Zoozve. But Earth also has a couple of quasi-moons, which are not moons or natural satellites. They are asteroids that orbit the sun and appear to loop around Earth from our perspective. So here is one of them. The first, and I think currently only named quasi-moon of Earth, orbit of 469216, or Kamo'olowea. Hope I'm pronouncing that right. The moon, or quasi-moon, orbits the sun, and its orbit is this yellow line, right? Earth's is the blue. It orbits the sun, right, as kind of in line with Earth, very close to Earth's orbit. But it also traces a series of loops around Earth, or it appears to, right, as it's orbiting. This asteroid, or quasi-moon, is one of the first ones that's been discovered. It's the only named one. And so part of this new name a quasi-moon is that there's another quasi-moon of Earth, asteroid. I really wish this GIF would play. All right, never mind. You don't get to see it. 2004 GU9, and it is a asteroid. It's also known as asteroid 164207, and it was the first quasi-moon when discovered 20 years ago. It's quite small. It's less than 1,000 meters wide. It's pretty little, and it's likely to travel alongside us for a while, until about 2,600, according to a study that was done in 2010. So if this GIF would play, which it doesn't want to, I don't know why PowerPoint hates it right now. This is the quasi-moon, and it is orbiting around Earth, but as Earth moves, it appears to move around us from our perspective, right? And so this is the competition. So the person who got to name Zoozve, which wasn't its name, check out the episode before, from Radiolab, and the International Astronomical Union are hosting a contest where members of the general public, you don't have to be American, it's open worldwide, can submit a name to name this quasi-moon, which is kind of cool. There are rules you still have to follow. So make sure you read those. There are still some, you can't name it anything you want. There are some things you have to do. But that is the link to go to enter, to submit your name or a name for the quasi-moon. You have to submit a name, and then also a citation, which is just a description of the name and what it means and why you want it to be named that. And submissions are open until September 30th. So you have time to think of a good one. And then you can submit, and it's, I don't know, pretty cool. I love when the IAU does things like this. You get to name a piece of space, and NASA's done this before with the missions, Perseverance was named out of a contest, Ingenuity was named out of a contest. And so it's always fun to, get involved in these sorts of space exploration or just space object activities. So I think I might try to come up with a name just for fun to see what happens. Haven't thought of it yet. Also, I feel like I need to have a pretty good justification. And I don't know if I want it to be funny or scientific, but I don't know, someone who watches should also submit a name.
Yeah, absolutely.
Cool.
Everyone watching should submit we've already got somebody say Marley, but
don't
we'd
that.
have to look, because I do know that one of the stipulations is that it has to be something connected to mythology, but mythology is kind of open-ended. And I actually did hear lots of Nasser talking a little bit about that on Planetary Radio, because their mythology can be many things. If it's in literature, right? Perhaps there's a way to say something in literature that's been, is there a timeline of when something becomes mythological? One of the more popular names that's actually getting a lot of steam right now is Quasi-mundo.
I like that, actually. That's fun.
So, but the other thing I should say about this too is that they were also talking about is that they have weird rules around ages. So if you're under the age of 18, you will need to submit through a parent. But it doesn't mean that you can't submit. You can also say that it's from me, but you will need to have a parent help you if you want to officially submit something, which I think is really cool. Everyone should get involved, because I think we should do more of this. We can't have these amazing objects with these long license plate-like numbers.
Yes. No, I agree. Well, okay. I don't want to knock the license plate numbers because they're sometimes very helpful. Like exoplanets also have those very
Right.
long, but that tells you a lot of information, which, the telescope that discovered it, that can be helpful. In this case, yeah, why not? It's just a quasi like it's not a huge thing. I did full find the rules. You're limited to a maximum length of 16 characters. So
Okay.
keep that in mind. Um, it cannot contain your own surname, I guess. Uh, um,
So Marley can't work then.
surname,
Okay. Okay. Well,
last name. Marley's not my last name. It could work.
well, I mean,
Um,
I don't think you can name it after yourself. I think that was another one of the things.
Right, yeah, I think so. And it's also cannot match the existing name of a satellite of a major or minor planet. So it can't already be named. So like they do have a link on the page that you can go through all the other names to make sure yours that you've come up with isn't on the list.
Hmm.
Um you can also do the full names of people. Like I know there's like a comet that's named like Mr. Spock, I think. So like you can do that. Um there are like some other rules that you can't do names of a commercial nature, so you can't name it Coca-Cola, for example, which I think is good. And you can't name it after political or military persons or events until after 100 years after the death of the person or event occurred. So
There you
history
go.
buffs out there is a time limit imposed upon you. And yeah, so there you go. That's
Okay.
some of the rules. Make sure you read through them because they are pretty. There's a couple that you should know of.
Well, we
So
should definitely do something formal with the Space Center. Maybe all of the staff we can all go vote. And all of you out there should vote. Thanos's glove. Kate Andrzejczyk on Instagram suggested that one. I like, because I think connecting it to something in pop culture, I think would be really cool because mythology needs to kind of break out of this kind of, Greek mythology thing that we're in. I love bringing in some
yeah.
more modern pop culture. I think would be really fun. So we've only got a few more minutes for this episode, but we got one more fun little story that I think we're going to get into in a little bit more in depth throughout this year because we have another really special event that people will be able to see with their eyes, potentially even in light polluted cities. And that
Well,
is, well, okay, you did, and that is a star doing some sort of explosion. Why don't you tell us about what novas and supernovas are, Marley, and tell us about this event?
yes. Okay, it's just a nova. It's not a
Yeah,
supernova.
right.
It's just a nova. Still cool, but not the same thing. So what is happening is that there is a star in the northern sky called T Coronae Borealis. So that gives you an idea of where it might be. It's near the uh Northern Crown constellation, which I'll show you in a second. And it's actually two stars. So there's two stars in the system, a red giant star and a companion star that is a white dwarf, right? The system itself is known simply, you can call it the Blaze Star, but astronomers just call it TCRB, which is just the name for it. It's about 300,000 light years from Earth. So it's far, but pretty close when we think about the distance from novae events that we can see. So a white dwarf is a stellar remnant. So this system would have originally been two stars, two main sequence stars. One would have gone through its life faster. It would have died faster and left behind a white dwarf. And the companion is still kind of going
Mm,
through its life. And so this red giant that it's its companion, this is like illustration or a person's imagination of what this looks like because we don't actually see it in this detail. The white dwarf here is accreting material from this red giant star. So the outer layer of hydrogen of this red giant star is being pulled in by this white dwarf's gravity. White dwarfs are very dense, so they have a larger gravitational impact than these other stars, and it's being stripped away. So that hydrogen being stripped away from this red dwarf creates an accretion, or red giant creates an accretion disk around the white dwarf. So this is kind of a better idea. It's a still from an animation from NASA that shows like the whole event. But
hmm.
as it's being pulled, the white dwarf's actually right here. You can barely see it because it's pulled all this material off, and now there's an accretion disk around the red giant. But this white dwarf is accreting all this material, and that's causing a buildup of pressure and a buildup of heat. And eventually, white dwarfs have a specific limit of mass they can reach. I think it's the Chandrasekhar limit for white dwarfs. There's two for something else, and it's been a while, but I think it's Chandrasekhar limit. And once they reach that mass limit, it triggers a thermonuclear explosion. So the pressure gets too high, the heat gets too high, that the accreted material explodes off of the white dwarf. It blasts it away into what we call a nova, right? So it is a very bright flash of material being pushed away. And that's what's kind of being shown in the still image, is that material being pushed off of the white dwarf. And from what scientists can tell for TRCB, that nova event appears to reoccur about every 80 years. So it takes the white dwarf about 80 years to accrete enough material for it to hit its limit and then blast it off in a nova explosion. So this cycle can continue on for tens or hundreds of thousands of years until basically the white dwarf destroys itself or runs out of material. We don't typically see a repeated outburst in human lifetime, and this one is relatively close to our own system. So it's very exciting because we could potentially see it ourselves. The first recorded sighting of the nova from this was more than 800 years ago.
Oh, wow.
Someone in Germany noted the observance of, quote, a faint star that for a time shone with great light. So it will appear as a bright star and then it will fade from the sky. It was last seen in 1946. And the behavior we've been seeing since is kind of the similar same behavior that was leading up to the nova that was seen in 1946. So if the pattern continues, as far as we can tell, the nova event will occur sometime in September of 2024. So this is kind of a early warning of get ready to look at it and figure out where you want to be looking in the sky, which will be easy because we're reaching summertime. And one part of the summer triangle constellation is Vega, which is this very bright star. And so to help find kind of what you're looking for, if you find Vega and then find Hercules, which is a more difficult constellation to find, and then it's kind of in between Hercules and Boötes. And so Boötes is pretty much nearly a circumpolar constellation for us here in the Northern Hemisphere. And the Northern Crown kind of sits in between the two. And the Northern Crown is spotted on clear nights. It will be helpful to get out of the city to see it. It is difficult to see in Metro Vancouver. But this is kind of the area you want to look. So get practicing, basically. We'll bring it up again later, closer to September, but get practicing. The other way is to find Arcturus. So one way to find Arcturus, I didn't get a picture, is to find the Big Dipper and follow the handle of the Big Dipper across the sky. It's like the arc to Arcturus is how you can remember it. And Arcturus will be the brightest star along that arc line. So if you just follow the arc of the handle, go all the way down or across whatever direction it is, that bright star will be Arcturus, and the Northern Crown is close to that as well. So get ready for something that might happen in September. Kind of cool. It will be visible to the naked eye for a little less than a week. So you won't have all the time in the world to look at it, but it'd still be fun to give it a go. It's cool. It's a really big moment for amateur astronomers and also scientific astronomers alike, because a lot of telescopes are probably going to look at this. So
Okay, well, put a pin in that. We will be talking more about this as we get closer to this event. We did get one final question outside of our topics today that we'll end off with, which is another classic question, kind of back to life, maybe in our solar system, and that is around Jupiter's moon Europa. What makes Jupiter's moon Europa really so intriguing in terms of its geologic activity? Like, what is it, besides sort of like the water? Is there something else going on with Europa that makes it intriguing for life?
It's really just like the water is kind of the biggest part of it. It's also the fact that there's a heat source generating that the ability for the water to still exist and not be ice. And so as Europa orbits Jupiter, it's being pulled on by the other Galilean moons as well as Jupiter's gravity, which creates a phenomenon called tidal heating. You can think of it as the moon is basically being like stretched and squeezed a little bit. And that stretching and squeezing causes heat in the interior, which causes the ice to melt, resulting in an under ice ocean. The other part is that Europa also is within Jupiter's magnetic field, as well as has an induced magnetic field, which is interesting because we have a magnetic field and it's very helpful for us. Who knows how helpful it is for Europa? But it is really just the water and the fact that there's a heat source happening. Because having water and cold is one thing, but having water and warm is another. And so it's a new type of world that we can explore. And because it has water, that's a big deal because that's the number one thing we're looking for.
Yeah.
And on like a personal note, there are so many weird creatures at the bottom of Earth's ocean that like there very well can be something super weird in that ocean. Like ocean life is bizarre. We don't really understand our own ocean life very well. So why not check it out?
Awesome. Well, thank you for that question, Davis G. Gracie. If you're watching and have questions, we will be back in 2 weeks with another episode that is going to be, I'm just looking at the calendar here. I always have to get my time frame here. June 27th. We are getting close to solstice, right? You can tell by the sunlight. I was going for a walk the other night. It was like past 11 p.m. and I could still see reds and blues over the western horizon past 11 p.m. from the sunset. So enjoy the solstice. We've got a big event tonight, the Night Sun. We've got Dr. Shandine Pete from University of British Columbia, who's going to be talking about Indigenous timekeeping and some really cool stories that he has done through his research. There are still tickets left. If you're watching, come on down. We're also going to be having our observatory open. The moon is visible before the sun sets. So come on down and look at the moon through our telescope. We will see you all in 2 weeks. Take care, folks.